Amazing piece of work you guys have done. Much needed and really valuable. So we just wanted to talk to you about it. And I kind of go back to I wrote about the CNN anchor who said, "Where the hell are the ventilators?"
Well, and the situation is very complicated. It changes every day. Now there's some clinical question as to how much ventilators should really be used, but I can't really address that,
Yeah. Well, could I ask, Robert, could you just give us a little bit, maybe each of you, and how you work together?
Okay. So I have a PhD in computer science. I was kind of a middle manager in software companies for a while. 5 years ago, I was a Presidential Innovation Fellow, and that really affected me. And after that, I sort of decided to create a charity where I could sort of do innovation work full time. So I created Public Invention, which is designed to do open source inventions for the whole world.
Ah, yeah, great.
I've been doing the internet for forever. I'm proud to say Vince Cerf is, unfortunately he has COVID right now, but Vince Cerf is a good friend of mine. I helped invent IPv6, and then I created something called 6LoWPAN, which drives a lot of the Internet of Things. I met Rob when I was, as a White House Presidential Innovation Fellow, focused on Internet of Things. And I've done a bunch of startups and whatever, but currently I'm the CTO for Industrial Internet of Things for Jabil. And if you haven't heard of Jabil, we make stuff. It's a $25 billion contract manufacturer, the largest US-based manufacturer. And so my job with them is we build for the 300 largest brands in the world. And so what I'm trying to do is get them out of their own way, because everyone's building their own islands of things and nothing's becoming the Internet of Things. But when Rob started working on this, I was like, we need to build this with open protocols and open systems and build this into the cloud so that there can be some view of the data and so people can see what the output of their other respirators or ventilators, and we can do third-party analysis on all of that. And Rob was like, yeah. So I'm doing the protocol work, and Rob and Lauria, who's joined us, are doing all of the heavy lifting on the electronics.
Okay. Heavy lifting for actually building a ventilator?
Well, sorry,
I jumped ahead. Rob, go ahead.
Robert, I was alerted of the work that you were doing as I was talking with a group in Portland that is working on a ventilator project, and they forwarded me the spreadsheet that you've put together, which is fascinating and detailed, and really is the most in-depth piece that I've seen in this regard.
So let me point out that Enrique and Avinash have been the ones working on the spreadsheet. And good. It led us to believe that testing was very important. So we created another project, which Geoff and Lauria are working on. At the beginning, thousands of engineers wanted to help. And they literally created at least 80 open source projects, which are on the spreadsheet. And over time, we've been adding them and analyzing them along various dimensions that we thought were important. And the first one on the chart is openness. And there are a lot of good ventilators probably out there which are not open. And so they're very hard to evaluate. It's very hard to tell what they even have. But I know of some that I believe have done a fair amount of testing, but they're not open, so you just really can't analyze them at all. So with the help of Enrique and Avinash, we built this spreadsheet that now has about 80 ventilator projects on it. And it's made clear that in some ways there are too many projects. And instead of building ventilators, what people need to do is to modularize the ventilator project itself so that your typical Make magazine reader can work on a small part of the ventilator, not be responsible for the whole ventilator themselves. And let me say, Make magazine, produced a community where before there were just a bunch of hobbyists that were unconnected. So I'd like to thank you for that. And it's kind of similar to what we've been trying to do here, which is to get teams to become aware that each other exist.
Exactly. Yeah, with their heads down often, they don't often look out to see what other people are doing. And that's kind of what we're trying to do in some ways, is connect. I love the openness thing, because it goes back to, Geoff, what you were saying in the idea of public invention that you were talking about, Rob, is we really, it's just shocking that we don't have open design requirements for this. And I see they're obviously at the top of your list. But, just the really important, that first category is really important, isn't it, Geoff?
First of all, you can't have these all built in one place and get them to where they're needed.
Yeah.
So the beauty of Make, right? The beauty of the whole community is makers in a local area can make things for the folks that need them. You did hit on something. I mean, Rob and Lauria and I have had the same problem with, supply chain issues and things. Everyone's competing for a limited set of resources. But openness, I think, is so critical for a couple of things. One, we're talking about life safety, health, and understanding how the thing works and its reliability can only truly be understood through the openness of understanding how it was designed and built. And Rob will get to VentMon, which is how can we do some verifiability of some of that.
Yeah. Could you, some of you I'd love to talk about the buildability section or criteria, because that's something we care a lot about. When we do projects for the magazine, we're looking at, are they replicable by others? You could have an incredibly clever design, but if you don't use common tools and processes, then it's not useful for other folks.
Lauria, I don't know, can you, or Rob, can you pull up the one? There was one company was talking about, you guys just sent me recently a new one and I don't know if it's on your list, but I looked at this thing and I go, wow, it's amazingly industrial grade. They said, oh, and here's all the specs make it. But exactly to your point, Dale, there is no way, right? This was sheet metal bending. That's all wonderful and good, but I don't know many people who could do that in any sort of time frame that's actually going to make a difference here.
Right.
Yeah, that's number 13.
Yeah, Prevail.
Real manufacturers, so to speak.
Yeah. So could you talk, Lauria or Avinash, a little bit about how, was this kind of just, it's kind of like what our editors do, is it's a read through and you kind of look at the complexity and you look at the parts and you look at the tool requirements. Is that how you evaluated buildability?
Yeah. In some ways we were doing that. I would pose the question to Enrique. He has done far more of these rankings than I have. But from my perspective, if the ability to use a 3D printer to fabricate this, that puts it at a certain ball game. If this can be done out of wood or very commonly acrylic sheeting, is something we see a lot of. That's in a different category. But we do see a lot of this thing of having sheet metal or some industrial grade materials used, and while it's a great ventilator, it doesn't lose points in buildability.
Just like how he was saying, whenever we're evaluating buildability, we're looking at how easy it is to make. Some of these industrial grade materials, they're not easily accessible by many people, and it's not just a problem in the US, it's a problem worldwide. So everybody has to have access to these materials to be able to replicate this in greater quantities.
Yeah. I see you have the criteria there. That's really awesome.
Yeah, we've defined the criteria. And from my point of view, it's a little different, although this situation is evolving. Buildability was actually whether the plans were clear enough for you to build it at first. So our idea is buildability is how hard is it to build one unit. We're attempting to create manufacturability, which is how hard is it to create 1,000 units, which has more to do with the supply chain, really, than the building.
Yeah, you look at column K, right?
Yeah, but we haven't been able to analyze that fully because our opinion is if you're not at buildability level 4, if you don't have clear enough documentation that an average maker in a makerspace can reproduce your thing, there's no point in talking about manufacturability because your designs aren't open enough for anyone else to make.
I think along those lines, right? If you need a $30,000 3D printer to the manufacturability has to go down, right? If I could print an entire ventilator with a relatively hobby grade 3D printer, that would be huge. Everyone could start to print things.
Yeah. And kind of, we're seeing that with face shields, for instance, but we don't see it with.
Well, or the one that I found fascinating, I mean, I'm sure you guys have seen it, the new things, the mask holders to take the pressure off the ears, because people are wearing masks now 8, 10, 12 hours a day. And those, the things that go over your ears, they're cutting into the back of their ears. And so somebody designed, actually there's a bunch of them designed, that are just little things that go behind your head to hold that off your ears. And everyone can print those.
Yeah. Let's see, we saw, you wrote a good piece on Medium in the end of March.
Been out for 3 weeks.
3 weeks, okay.
Improving the whole time. And the teams have been getting a lot of things done too.
Just to stay on these categories, is there anything else in the criteria? Is actually one of the questions we had, and I think since you showed me that, we can
you can
just
see
read
it.
that.
It's linked in the spreadsheet. So I mean, one thing that is important to understand for the average maker who wants to consider this is many of these designs might not be COVID-19 suitable.
Right.
And unfortunately, even the doctors are unclear on exactly what is needed. And they're learning things. Every week they learn some new things about how these things should be treated. But I do want to emphasize to people, this problem requires very, not precise, but careful control of volume and pressure. You can't just have a motor and hope it's going to be the right volume and pressure. You have to measure it and test it.
Right.
And building this spreadsheet, I think, has convinced people that this problem is 90% testing and 10% design, or at least it's more testing.
Right. How much of this is sort of, in a sense, computer engineering, meaning sensors and electronics to control what the machine is doing?
Well, that is a very good question, and it depends. Many of the things favor the AmbuBag design.
Right.
I guess you guys have seen an AmbuBag.
Right.
I've got one right here. Because it's relatively safe to do that. That is, if you're pushing it, a software bug is not going to drive too much air into the lungs of the
That's
person
right.
and harm them.
Right.
Okay. But other designs, like the Medtronic and other designs that use a drive mechanism that's a blower or a fan instead, they, in my opinion, really have to have sensor and electronic stuff. But many of them have a relatively primitive sensing system, and they trust the AmbuBag to limit the volume going to the lungs.
I was trying to understand more basically these two categories. I mean, there's sort of the automation of a manual ventilator,
Right.
and you're just kind of replacing human hands. And then there is the, there's just the more control, which usually requires a technician or a professional to be doing that. And it's, is there a name for, like the AmbuBag sort of is kind of been the name based on, in a sense, the BVM style thing. Is there a name for the more complex one?
No.
Okay.
All right.
My understanding, so there's the AmbuBag approach there, and then the ventilators. From the research that I've done and the learning that I've done, getting up to speed very quickly on this, the older style of an advanced ventilator used compressed air of some sort, and then newer, more advanced styles like the Medtronics use a built-in turbine.
Right.
So my understanding, there's 3 different types of ventilation systems, but there might be more. I'm still learning. So are there other styles, other approaches that exist?
Well, you could argue that there's a very interesting design called the Army ventilator, which is purely pneumatic, and so it does use compressed air, but it uses a carefully controlled valve, and it actually has no moving parts. And it uses a very tricky aspect of fluid dynamics to make sure a moving stream goes into the lungs until the patient starts to exhale. And then it's actually a bistable pneumatic device. And so then the airstream switches and the pressure is left off the lungs. And this was designed in 1965, and it's a funny story. The guys who did it couldn't figure out from the Army paper how it worked. So they went to a gallery and bought one. and reverse engineered it.
Oh, that's interesting. And so is someone, the Army ventilator is number 12 on your list?
The problem with it, with the Army ventilator, is it's very unclear that it's usable for COVID-19 type illness.
Right.
It, you know, in 1965, it may have been state of the art, but it's
right.
You know, it remains unclear if you build one of these things, if any doctor is really going to use it. So we've proposed a process for how we could open source the verification of these ventilators as well. So the idea here is, in order to convince, you know, rightfully skeptical medical administrators or the government that something works, you have a high burden of proof in this case. So we've outlined a process where a different team could build it, and then yet another team tests it. And then that test data is collected and presented to a medical authority. Whether a government has approved it or not, you know, it kind of has a thud factor, right?
And Rob, it's captured and stored and preserved.
Yeah.
Well, right. We're building a system. Geoff is building the software. We're building a system to do the testing. So even if you build a ventilator and it works perfectly and it has very few sensors, you have to put it on what's called a test lung to see how it behaves. And these things are fairly expensive, between $5,000 to $20,000. And so we're building a kind of cheap one that can be a monitor as well in the VentMon project. But other teams have either gone to hospitals or found someone who has a test lung in order to test their system once they get far enough along. So even if you don't have a lot of sensors in your system, you really have to test it on a highly instrumented machine.
Yeah. Yeah, that's interesting you're doing that. And, you know, again, this is also a problem a little bit, you know, when I ask about government testing, they may or may not be doing it, but they're not putting out, you know, detailed information. So, you know.
Well, I suspect the FDA is not going to functionally test anything, because they don't normally functionally test anything. What they do is they have the doctrine of substantial equivalence. It's your job to show that you are equivalent to an existing approved device. And if you present enough data, either clinical data or in the emergency sense, it clearly doesn't have to be clinical right now. But you know, if you show you can produce volume and pressure equal to a commercial ventilator, I would assume the FDA would look favorably on that.
Mm-hmm. But I've also heard that the FDA is confused about open source things, that they've said to one person, we regulate products and companies producing products, not open designs. So it'll be interesting to see where they go with this.
Well, I think it'll be interesting to see, Dale, what, you know, I mean, when push comes to shove, if we start to run out of ventilators and the need becomes so great, I believe, you know, doctors, you know, do no harm, right? But if it's going to save someone's life, you know, and our thought also was, you know, people are saying, well, what if I'm stuck at home or whatever? Could I use a CPAP and APAP machine? Well, I think VentMon might be able to answer some of those questions.
On our spreadsheet, we have a column for FDA or other national emergency approval, but many of these open source teams, if they're seeking that, they haven't told us yet. I hear rumors that people are seeking it, but they haven't really made it public.
This is kind of we're working out the open, showing your work, letting other people peer review it and criticize it and improve it. You know, that's very different than the way industry and government work these days. So I really think this is extremely important. You know, the other thing you mentioned about ventilators that I've heard, that, you know, some of the issues is to provide ventilators that release other ventilators that can be used on COVID-19 patients.
That's right. And many of these devices, even if a clinician didn't think they were appropriate for an ICU, might help relieve that pressure on the people whose disease was not that severe, you know, and potentially in other nations where they don't have a bunch of CPAP machines at home. I think you're right. The government agencies right now probably don't understand our point of view that an open source project is more trustworthy because it can be vetted by an enormous number of people and it can be built independently.
Right.
Whereas if right now in this crisis we're in, without testing, if you're closed source, you're simply relying essentially on your authority. Perhaps you're with a prestigious university or something, answering a questionnaire for the FDA to believe that your system works.
Or you think you have connections, right? And you're representing that you're connected to people that have that authority.
You know, this is entirely parallel to the debate we've had for 20 years over open source software and security and reliability. You know, third-party verification of all of that and such.
You know, there's many information problems that we have associated with this virus, you know, and it's a lack of trust in sources of information, say government or industry that have their own political agenda around it. And that's why I kind of see this sort of community response is actually doing work that I trust it because I know real people are doing it and they don't have a real axe to grind. You know, and so when I saw, you know, I saw your work, boy, that's exactly the work that needs to be done. And we want to learn more about it. And, you know, that whole category of testing, not just in ventilators, but in almost all of this is an authority replacement in a way, but we need authoritative processes here. So let me just ask, what's your own sense of the reality of open source ventilator projects? Like, are we going to see these things come in time to contribute? And given your proviso that maybe they're not, you know, it's not always clear whether they'll be used or needed in the capacity that we've thought.
Well, I have to speculate here. Mm-hmm. Integrating news about Ford, GM, Tesla, and Dyson building ventilators and the current apparent demand for ventilators that seems to be stabilizing, I would say probably these will not be used in the United States. But I would not be at all surprised if one of these designs or a variant, something that grows out of one of these designs, is deployed in the thousands in some of the places that have less resources than Europe and the United States.
Yeah, that's a really interesting point.
That's one of the pieces that I've been wondering about quite a bit as well, and that's based off some of my conversation with Jose at Maker Health, Maker Nurse. That, you know, we are lucky to have a large set of resources here, but they're in the developing world. They're going to have to be a lot more resourceful as things continue to ramp up.
Yeah, I think in the developing world we haven't seen the hockey stick yet.
Yeah,
of the cases. Yeah. Whereas here we seem to be doing a good job of sort of flattening the curve. To your point, Dale, though, no one it is about testing. Right? Yeah. We have no clue what the denominator is here in the United States.
I want to go back to actually your idea on modular components.
Yeah.
Like if I were to say, hey, makers, you know, pay attention here. You know, there's still an opportunity. You know, we've got face shields, we've got masks going. Like, some of you that can do this, here's a direction to go in.
Yeah. Well, so I've written an essay on Medium recently that does outline this, some of this, and I would like to point out we're working with the team. Lauria, could you bring up Jenny's repo real fast? I tried to get it ready, but I may not have it. One of the things that we said needs to be done is to modularize the user interface, because the doctors who are using this are going to be exhausted and they're going to be wearing PPE and they're going to be gloved, right? If you give them an emergency pandemic ventilator, it has to be easy for them to train on. They have to understand it.
If everyone looks different, it becomes complicated for them.
Right. You may have the best user interface, but if it's different than what they're used to, it doesn't matter. And so I believe the Israelis with the AMBO vent did a pretty good job with a simple user interface, but we believe the maker community could standardize a controller just like a Nintendo controller is standardized on it.
Folks reached out to Rob with exactly that. They've come up with the ability to a manufacturable, right, and a buildable and a makerable standard user interface or doctor interface for this.
That's great. Is this it?
So that's part of it.
That's it. If you scroll down, there may be other pictures of how it would.
Yeah, but the beauty of it is, right, again, we want something low cost and accessible. And so rather than, where a lot of people might jump immediately to a quarter VGA screen with a fancy display and blah, 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 blah,
Right.
What they did was they took relatively available components and put them together and then are building it on an Arduino Shield design so that it can just sit on top of an Arduino. The beauty of that is it's a perfect Lego piece to fit to our VentMon, right?
Yeah.
There's no overlap.
Yeah, that's great. And who's behind this Delphi project? Is this
Professor John Bennett of UC Boulder, and it's co-led by an artist named Jenny Filippetti.
Awesome. I love that. Okay. And when you say I didn't quite get that, Geoff. What are you referring to there?
So let me explain another important aspect of modularity. We have designed this system called VentMon based on this work that we did, and other people should do this as well. Like, it takes more than one team to make this happen. But the idea of them is testing is done on a bench, but in every ICU, the respirator and the ventilator is monitored. If something goes wrong, if you lose power, if it doesn't provide enough oxygen, the nurse's station rings a bell. There's an audible alarm and a visual alarm saying something is wrong. Many of the open source teams delayed implementing that. The people on the spreadsheet have not done monitoring. Understandably, they were trying to address other problems. But the British spec, which is very important, which sets out minimum guidance, at least as far as the UK government, for what is clinically acceptable, says you have to have monitoring of the ventilator at all times. So we, following the open source playbook, have created a GitHub repo where we're building a hardware device that plugs into the airway that, if on the bench, it can be used for testing. But if we can further refine it, it could go into an ICU as a monitor to provide either redundancy that the thing has not failed, or to simply be the control mechanism for a ventilator that someone else built. So that sanitizability and the UI are like three things that can be modularized right now. There are probably more.
Mm-hmm.
In sanitizability, I mean a UV filter on the exhalation pathway.
The idea being, think of it again as, and I'm waiting to see a ventilator built out of Lego pieces, but on the output side of that's what we're thinking of, right? VentMon is just a Lego piece that could be attached to the sanitizer, could be attached to the next piece. You can plug them together to build something much more supportive for the end user. But we want something low cost that could be used, as Rob's point, can be used to test, do third-party validation that this ventilator is going to do no harm, that when you set it to these settings, it actually does that. We get data, we capture that, we hold it, but also these could be built and put onto ventilators that are being used in a facility and can alarm if something goes out of whack.
Is there a reasonable definition of what the various subsystems are in a ventilator?
Well, that's this diagram. I created this thing called the Corovamp abstract physical model. And although these are life-critical machines, they're way simpler than an internal combustion engine. Mm-hmm. And basically, every ventilator has components that can be mapped onto this diagram. They sometimes move them around a little bit, and they use different mechanisms for what happens where. But basically, no ventilator is more complicated than this diagram.
Mm-hmm. Robert, just let us, how did you figure this out?
Well, I haven't
spent your career in medical devices, have you?
I've been learning, and although I don't get paid by public convention is my full-time job. So since March 15th, I've been doing nothing but trying to learn this as fast as I can and contribute in whatever way I can.
Yeah,
and Rob doesn't sleep.
Really? Well, I actually love your setting there. It looks very makerish. Okay. Well, listen, we really appreciate your time and your work. And, I'm trying to really, the interesting to me is the collaboration in the community and how things go. And people are really open to that, and they're moving. This is I think a unique time. And if we could actually learn as much from this as we can, we have a new engine, for innovation in the country. So thanks a lot for your time, folks, and we'll see you down the road. Bye.
Thanks.
Okay. Thank you.
Yep.